Hey everyone, welcome to Pilot Math. We're going to do a quick demo here of the quadratic equation and a quick way to derive it. Pretty standard stuff here, nothing exciting, but yeah, gotta start somewhere. So we have ourselves a quadratic equation, ax plus bx, ax squared rather, plus bx plus c is equal to 0. And we're just going to place a restriction that a is not equal to 0. The other constants can be arbitrary. And what we're going to do is we're going to apply the completion of the square. Complete the square. And through completing the square, we're going to be able to solve for x in general. So taking a look at this, completing the square is actually rather misunderstood in my opinion, because it's just a formula. If you have a binomial that looks like x squared plus b prime x, I use b prime so you don't get it confused with this b over here, you can factor that as x plus b prime over 2 squared minus b prime over 2 squared. FOIL this out and everything cancels back down to this other side. So what we're going to do is we're just going to make these first two terms here look like the first two terms here. To do that, we just need to divide by a. So a is non-zero, so this is allowed, plus c over a equals 0. So now these first two terms match, and b prime is apparently b over a. So applying the formula, it's x plus b over 2a quantity squared minus b over 2a quantity squared plus c over a is equal to 0. Okay. Now, just following a standard algebraic trick, we're going to move everything that doesn't involve x, that's these two terms, to the other side. See what that does for us. So we have x plus b over 2a, oops, I deleted my parenthesis, squared, equals b squared over 4a squared, because when you square a fraction, you just square the top, square the bottom, minus c over a. Now I hope I didn't do too much here because I squared this and moved it to the other side with subtraction. And now I'm going to do one more thing. I'm going to actually combine these fractions. So to come up with a common denominator, I'm going to multiply this second one by 4a over 4a. That's just 1. But when you multiply this out, you get a common denominator. So this whole side can be written over 4a squared. So it's b squared minus 4ac over 4a squared. That equals x minus b over 2a quantity squared. Now there's this thing called the square root property, which says if you have this situation where you have something squared equals something else, you can drop the square. This should be plus. I caught that because when I do math, I always look back 2 or 3 steps and make sure everything's transferred and copied the correct way. But if you have that situation, square root property says square root both sides and add a plus and minus. So b squared minus 4ac underneath a radical, also under that radical, 4a squared. And at this point, I'm going to take the radical of the top and the radical of the bottom. And I'm also going to move this b over 2a to the other side. So minus b over 2a plus minus radical b squared minus 4ac. Oops. Now why are you not working there? Over 2a. But those have the same denominator, so we can combine that as negative b plus minus the square root of b squared minus 4ac all over 2a. And what we've done now is we've gone from a quadratic equation using completing the square all the way down to a solution where x just looks like this expression. So this will allow us to solve anything. And there's one interesting tidbit about this, and that's the thing under the radical, this b squared minus 4ac. It's called the discriminant, and we're going to look at that more closely in the next video. When you compute this value, I suggest computing the discriminant, taking its square root, and then moving on. Anyway, that's it for today. Have a good one.